Welcome to the TimCo Retail Manager course. This course focuses on real-world application development. In this video, we're going to be taking advantage of some of the features we now have in our .NET Core projects. Specifically, we're working with dependency injection, logging, and the configuration system. Now, Patreon members, don't forget to head over to Patreon to get the source code for this video. If you aren't a Patreon member and are interested in getting the source code for each TimCo Retail Manager video, head over and sign up at the $5 per month level or higher. Now, if you're not familiar with this project, let me explain a little bit about it. We created the TimCo Retail Manager application as a set of simulations of the real world. We started with a .NET Framework set of projects and upgraded them to .NET Core in order to gain the experience of doing an upgrade like that. You see, I'm a firm believer in experience. Seeing someone do something is not the same as doing it yourself. So I always encourage people to follow along with me so you can get the experience of doing the work. Then you can do something similar on your own to ensure you've grasped the concepts you're learning. This is how you grow as a C# developer. Now, if you want to catch up to where we're at now, I bundled all the videos and source code into a course on my site. You'll find a link to that course in the description. Okay, let's move over to Visual Studio. Now we're going to mainly focus on the API side of things this time because the API, if you remember, we did not have any type of dependency injection. The WPF project, we used the dependency injection that kind of comes with Calibre and Micro. It's familiar to Calibre and Micro, and it's pretty simple. And so we set that up to work with Calibre and Micro. So we had a dependency injection system. But with the API, every time we need a new instance of something, we just new it up. We just instantiate it right there. And that caused some friction. So what we're going to do is we're going to go into the API project and start replacing all of these things. So let's go to the inventory controller as an example. And right down here where we need to get inventory data, we say inventory data equals new inventory data and pass in the configuration. Well, this right here is not using dependency injection, but we have dependency injection configured. We're using it. It's just that this code that we upgraded didn't use dependency injection. So we didn't take advantage of these .NET Core features we have built in now. So let's start making this work. And here's where you're going to get into a little bit of a sticky situation because there's dependencies all the way down, which we've got to put in a dependency injection. But it does mean we'll need to make quite a few changes before we can even test one change. For example, the inventory data, if we go there, I'm guessing that it has, and it does, a dependency on SQL data access. That's a newed up instance. Well, we need to ask for that from dependency injection, which means now we're going to break all the calls that call this inventory data class, which is okay. But that means we have to change a lot of things. Well, I bet if you go in SQL data access, it probably has, well, we got this get connection string here. And that is using I configuration, so that's good. Let's just see if there's equal to new SQL connection, but that's okay. We can do that. We want to keep that there because it's in the using statement. So it maybe we don't have any other dependencies in here. We do have hey, log this, but there's no way of logging right now. It also looks like we have some leftover comments we should get rid of. In fact, let's just do that while we see them. So we should probably pass some logging into this so we can log that exception message. And we should then change this to pass in the inventory data. And inventory data, that should also pass in a SQL data access, which SQL data access right now is internal. We want to change that to be public. So there are a few changes we have to do. let's start from the top. And let's just work our way down. So we have this equals new inventory data. Let's open up the startup. Yes, it's startup. I always get confused. Is it startup or is it program.cs? But it's startup that has the services configuration. And this is where we can add services to the container. And we'll do that. Let's do that right after Razor pages. And we'll just say that these are our personal services. So services dot add transient, and transient means we're going to create a new instance every time we ask for it. And what we want is the inventory data. So inventory data is right here, but here's the problem. That's not going to allow us to make it easily testable because it's an inventory data. It's a class, not an interface. So let's create an interface for this. Actually, not create an interface like this. Control dot, extract interface, new file, and now we have an inventory data. This will allow us to replace this inventory data concrete class with a different class, maybe a mocked class or something else. So inventory data, control dot to add that using statement, and then inventory data. And what this will do is every time we ask for an inventory data, it will give us inventory data. Now, if you're confused by that, I do have a full video on dependency injection. But the basic concept is that we create this tool at the very top in our user interface that says whenever you ask for something, in this case an inventory data, here's the instance I want you to create. So say equals new inventory data. And that's the instance we want to create. And so that will, instead of us here saying equals new inventory data, instead, this is going to do it for us and pass that new instance to us in the constructor. The benefit there is that now we can change what our dependencies are at the very top, at the user interface level. We've inverted our control. We've said that the user interface tells you what your dependencies are, or what the concrete results of those dependencies are. That way we can change things out if we need to. And the biggest place we change them out is in unit testing. When you unit test, you don't have to follow this prescription of when I ask for an inventory data, we get this. Instead, you can create your own class and you can more easily control the environment. So you don't have to be testing a full end-to-end test. You can test just one little piece and everything else can be pretend so that we know exactly how that one piece works. So again, we got a whole video on that. That was a 5-second primer that hopefully shed a little more light on it, but it's definitely not the full picture. So we have inventory data, which means that now instead of doing this, we can ask for an inventory data. And we'll call this inventory data is probably fine. And then control dot to create that field. So now we can say instead of data here, we can say underscore inventory, get inventory, and not have to do this instantiation at all. Down here, same thing. Now note that inventory data, that's actually going to be the inventory data asks for an configuration. Dependency injection sees that and will take care of that automatically for us. So you don't have to pass in anything to our constructor. Now, while we're here, we also see that SQL data access is being instantiated in our inventory data. Let's take care of that. First of all, let's change this from internal to public. And we're going to create an interface for this. Now note it does have two interfaces now, and that's okay, that's good. So now with this, we can go back to our startup.cs. Let's pin that. And startup.cs, we can say services.add transient, iSQL data access, control dot to add our using statement, SQL data access. And again, transient just means that we're creating the instance every time we ask for it. If we said singleton, we'd create one instance and use that over and over and over again across the entire application. So with this now, we have the ability to, instead of an inventory data, instead of saying equals new SQL data access, we can just ask for iSQL, not iService, iSQL data access. And let's call this, let's call it SQL. And then control dot to create and initialize that field. And then we can just say underscore SQL. And we don't have to do that. Like so. And that takes care of replacing that dependency. Now the dependency comes from the top. Okay? So now let's just do a quick build. And let's just build the whole solution just in case we had any other issues that kind of tripped. And we may have, right now there's no errors. That's good. So there's no errors. There's 8 warnings. We can ignore those for now. And no errors and 8 messages, which we can also ignore. Okay, so now that we have that done, let's close out of this, and look to see if there's anything else in here we're instantiating. Now, we do ask for the config, but now we never use it. We were just passing that into our instantiation. We don't need to do that anymore, so we can get rid of that for now. We might need it later. I don't think we will. Therefore, why ask for it? So we can get rid of that. Let's go down to the product controller and look at this. And we're saying equals new product data. Okay, so let's go to our product data. And let's create an interface for this. Control dot, extract the interface, hit OK. Now that we have an interface, let's go over to our startup and say, let's just copy this line here. iProduct data. And this is product data. So now we have that. We can ask for it. So let's just look inside of product data itself. And that can ask for, well, first of all, does it need the config anywhere? I bet it doesn't. We'll see in just a minute. But iSQL data access, call it SQL. Control dot, and create that field. And now we can say underscore SQL, and we can get rid of this line right here. Again, we can say underscore SQL and get rid of this line right here. The line we're getting rid of is the instantiation. We don't need that anymore. Now with those two removed, it looks like config is a darker gray. Notice that versus the SQL. And that's because we don't need config anymore. So let's get rid of iConfiguration. And that should take care of product data, which means that the controller, instead of instantiating that, which also we don't need config, so let's get rid of it. What we can do instead is ask for an iProduct data. Let's call it product data. Control dot. And then here we can get rid of this and say product data get products. Okay, so now again we're asking dependency injection for that rather than instantiating it ourselves. Sales controller, my guess is we're going to go to sales data, so let's just take care of this now. Sales data, we have instantiation of product data. Okay, so we're going to ask for product data and control dot to create that field. And instead of products, which where are products down here? Right here. So instead of products, we're going to have product data, like so. So now this product data is product anywhere else in this method. There's a lot in this method, isn't there? Might need to refactor at some point. It seems like it's a little heavy in what it does. Well, let's get rid of products. We don't need that anymore. And it looks like it's still okay. It looks like there's no problems here with this. Okay, now let's continue on here. Let's kind of review just down to the list. I think we've got everything we need to with the product information or product data. But let's go through and look at the other. We have a lot of equals new. Now, equals new list of model, that's okay to instantiate because we don't really use the dependency injection system for something like that. Now we do have this config helper, which we're going to look at some point. Because I think that instead of having a public static class, we might want to do this in maybe a singleton or something else. All right, so that's a thought, but we'll leave it alone for now. Now, equals new sales model, that's okay because again, it's an instantiation of a model, which is different than instantiation of a class that has any type of logic in it. So there's our instantiation of a class with logic, and that's actually coming from a dependency injection, which is good. And then down here, looks like this is all fine. Now we have instantiation of another model. That's again okay. And then we have a tricky one. This is a using statement for SQL data access. And the reason it's a using statement is we want to make sure this gets disposed of properly. So how do you deal with disposal when you're using dependency injection? Because it gets created or instantiated for you. So you can't use the using statement traditionally. Okay? Well, the good news is that if the dependency injection system creates something, it's responsible for disposing of it. Therefore, as long as you implement the iDisposable, which we do, then the dependency injection system will dispose of it for us. We don't need the using statement. Now, it doesn't mean that we control when it gets disposed. So there may be a difference in how long it holds on to that instance compared to what we were doing. And so there may be a case for us manually calling the dispose method, which remember that dispose method can be called more than once because of how we designed it. But we don't have to do that. So with that being said, what we're going to do is actually request an iSQL data access up here. So iSQL data access called SQL. And then we'll initialize it as _SQL. And then down here, we can get rid of this using statement, which means we can also get rid of that closing curly brace. And we will Shift Tab to move this back one level. So it's in line with everything else inside this method. Now SQL becomes _SQL. There we go. And now that has properly handled our instantiation and use of that SQL instance. Down here we have an instantiation of a SQL data access, which we don't need. We can just use our instance. And that's it. So with that, we can save this. We do need to come up here. I don't believe we need config. Nope, it's grayed out. Therefore, we can get rid of iConfiguration. And now I think we're done with that. So there's a sales data. We don't have the iSales data yet, so control dot extract interface. And now with this, we can go to startup and we can copy this line and say iSales data or sale data and sale data. And now if we go to our sale controller, we can ask for an iSale data, sale data, and instantiate that. And then down here, instead of instantiating a new instance, we can just say underscore sale data instead of data. All right, same thing down here. And we can get rid of the old way code here. We don't need that. And that takes care of the sale data controller. We can close all this stuff out so that we don't need, we don't have extra stuff open. Now let's go to the token controller and see what we need for the token controller. We have a new object result, which is a basically a model or close to it, so we don't need to touch that. And down here, new claim, again, same thing. Claims, headers, we're all good there. The one thing that we need to talk about, and we'll do it in just a minute, is this my secret key is secret, so do not tell. We need to extract that from the code because that's not great to have in the code. That's a demo value, but we want to be able to change that to a production value when we publish this. And you can't do that if it's in the code. Well, you can't do it as easily. It is possible. Don't do it. Put it in your configuration files. So we'll do that in just a minute. But the token controller is clean. Go to user controller. User controller, it looks like, by the way, in sales controller, did we get rid of iConfiguration? We did not. Are we using iConfiguration somewhere? We are not. Almost forgot that. Seeing it in the other file reminded me. All right. So now here, let's come down and look to see if we instantiate anything. We do, user data. Well, what's user data? User data is something we need to convert over. So let's get rid of iConfiguration and instead ask for iSQL data access called SQL. We'll instantiate that. Not instantiate it, we'll create the private field for it. And now with SQL, we don't have to do this. And instead, we can say underscore SQL. And this line right here, I'm not sure if we need this. Because essentially, what that's saying is, whoops, lowercase new. That's all that is. And see that ID equals and how it's grayed out as an underscore here. That's because it's the same variable name as it is the property name. Therefore, we don't have to specify the property name and the variable name. It can be assumed. So that cuts down the code a little bit there. And that's all we need for user data. So now we can control dot and extract an interface. Come over to startup and say user data and user data. And now in the user controller, we can ask for the user data and control dot to create initialize a field. Which now that we have this, we can say user data and get rid of this. Down here, this is an instantiation of a new list of model, and that's okay. Instantiation of a new model, that's okay. We can get rid of this demo or code we don't no longer need. Okay, that looks good. Down here, that looks good. That looks good. And I don't believe anywhere in here we need our configuration. So config is grayed out again, so we can get rid of that. We can get rid of that line. We can get rid of that line. And now we're all set. So now you've started to take advantage of the dependency injection. Let's just make sure that we're not using instantiating things somewhere else. So what I'm going to do is I am going to, let's search first just this project, and we'll search the library project as well. So Control F, I'm going to say equals new. The current project, I could select the current solution or the entire solution. I don't want to do that because I don't want to confuse us with the other projects. So let's do the current solution and let's find all. And I'll show you why. Let's go to find next. I'll show you why. Find next. Okay, it found one, the user controller. I'm not going to read which these are yet. I'm just going to show you if we step through this. I'm betting, there we go, bootstrap.js. Do you care about the fact that Bootstrap has equals new? Well, no. We're not modifying JavaScript. We're modifying C# code. But since it's in the project, it will search it. So instead I'm going to say find all. What this does is going to find everywhere that equals new is listed. And the cool thing is it groups it by the different sections. So we have controllers, we have models, we have startup, we have www.root/lib. So there's 81 total equals new somewhere in our code. There's 6 in controllers, 1 in models, 2 in startup, and 72 in our library, which is probably JavaScript. So there's bootstrap.js, whole bunch of different ones. And then there's jQuery validation, jQuery distribution. But the cool thing is we can ignore those and just look at the ones we want. So in startup, we have this one right here. If you double click it, it goes right to it. In this case, equals new token validation parameters. That's okay. It's basically a model. All right. Now, notice this is kind of like it's a whole new tab. So tab is find equals new. So we can pin this even. Let's unpin that. And now that this is pinned, I can just double click on the next one. It goes right to it. Equals new symmetric security key. Again, we're not going to put that into dependency injection. So those two are good. Models. Equals new dictionary. Yep, that's fine. Don't need to put that in dependency injection. Token controller has 4 of them. Equals new list. That's fine. Equals new token. That's fine. Equals new anonymous object. That's fine. And equals new token handler write token. Again, we'll leave those all alone. So for there, we have 2 in the user controller, a new list, and new application model or application user model. Again, model, those are fine. So with that, I have reviewed everywhere we have equals new, and I can close this out. So I searched my whole project, the whole front-end project. Let's go over to my library. Let's close all but pinned. And now what I'm going to do is kind of collapse some of these things down. And let's go to our other project, our library. Let's just open up one at random. I'm going to do the same Control F, and I'm going to say equals new again, current project, and again, find all. It's going to find all of the available ones. So we have, let's say it's still running here. So we have our sales data equals new list of model. That's fine. Equals new model. That's fine. Equals new model. That's fine. New SQL connection. Well, that's not fine. Yes, it is. Yes, it is. Because that's inside of our SQL data access. We don't need to put this SQL connection instantiation into dependency injection, because at this low level, this particular class has a firm dependency on this that we're not going to change. And so we can leave this one alone. So wherever it says equals SQL connection is fine. Equals SQL connection, that's fine. So these are all fine to have. And it looks like that's all of the instantiations we have in our library. So I think that we have a clean bill of health. We've moved everything over to dependency injection. Let's make sure it still runs. Let's close these things out. And let's hit start. Okay, it's starting to start up. And we've got our API has started. Looks good. And there's the Kestrel behind the scenes. And we have our WPF application. Let's log in. When we do, we get the cart. We can add items to the cart. If we add multiple, it updates them. If we go to our user management, we can see the roles that Tim has, admin and cashier. We can even add the managerial role or remove it. And that all works. So now we can also log out and we can exit. Cool. So our application is still working. Nothing has changed. And yet we now have a working dependency injection system for our API. That makes me feel a lot better. Let's go over to our change list. Notice all the changes we have, quite a few. And what I'm going to do is select all the changes and say stage. If you're selecting everything, you don't have to do that. But I like doing that because then you're forcing yourself to say, yes, I chose all of those. There are cases where I have things I don't want to check in as source control. Typically, it has to do with I put temporary credentials in for a connection string, and I don't want to commit that to source control, but I want to use it for testing. And especially if I pointed to a server that has a login name and password, if you just let it default to everything, then you will commit that connection string, which I have done, and then that's in your source control, and you have to back it out of your source control and erase all history of it being in your source control, and you should probably also change the password. So it's kind of a pain. Instead, you want to make sure that you are specifically choosing what you want to add to the staging environment. And a quick message here, let's just say add DI to the API because, abbreviations are cool. Let's commit staged. And we're not going to push that up or sync it yet because we still have more work to do. But that's kind of like step one. And it was a set of work. And so with that, I committed all that set of work together. And then I can commit a separate set of work when we do the rest of the stuff. So let's look at just a little bit of logging. We're not going to go too far into logging, but I do believe in here we had a to-do. And if I look under my task list, there, log this issue. So in SQL Data Access, we have this log this issue if we try to commit a transaction and it does not commit. We're basically just eating this exception. We're not doing anything with it, which typically you shouldn't just eat an exception. You should at least record it. Well, that's what we're going to do. So we're going to log the issue. But first, we need to ask for it. So up at the very top here, I'm going to ask for an iLogger. And let's do Microsoft.extensions.logging.abstractions. Install the latest version of that package. And we're going to say iLogger, and this is of type SQL data access. We'll say logger, control dot to create and initialize that field. And then right down here where it says log this, let's catch the exception. We can say logger dot log error. And it's going to say, what's your message? It's one option. Event ID or exception is the third overload extension. So we can say EX for our exception. And then we can log any message you want to give here. So let's just say empty string for now. This is our dispose method. So commit transaction failed in the dispose method. That's kind of a cleaner message we can show the user. But we also have the exception, which has the actual message as well as all the details about that message. So this is probably what I'd show the user, and this was going to go in the logs as a prettier statement. But this will also go in the logs, and it will have all the information you need to track down what exactly happened. So that's how you can add logging to SQL data access. And we get rid of that to-do. Let's just look through our to-dos and see if we have any more logging. Interesting that there's some JavaScript in here. That's odd. But otherwise, it looks good. I don't think we see any more that says logging. Make this better, but that's it. But I do want to add a little more logging in our controllers. We will get, by default, logging of whenever you're calling a method. So if you watch the Kestrel, it shows you whenever a endpoint is called. However, I want to do a little bit better in the user controller. So the user controller, if we look down here, we have some admin functions. These are things that only admins can do. So we have get all roles, we have add role and remove role. These are bigger deals because these are things that we need to make sure we know who did it and when it was done and what was done. So let's do this. Once we capture who the user is and find all the information about them, then we can do is we can actually log this information. Now you'll also want to know a little more information about this person. So this user is the user we're adding to this role. But we also want to know who is the user that's authorizing this or doing this. And for that, if we scroll up here, we see the way we can get the user information about who's logged in. So this is this get by ID. What this is doing is finding the user's information based upon who is logged in. So this is the based upon the name identifier. Let's find the user ID, and based upon that, let's get the user data. So we're going to get all this information. We're going to come down here to just these two, where we're doing a change action. I'm not going to worry too much about getting all the roles or getting all the users. That doesn't concern me too much. It's when a change is made, where we're adding a role or removing a role, that I want to make sure I log additional information. So let's capture this information up here. We're going to make some name changes here. And we're going to say this is var logged in user. And this is logged in user ID. And we'll let's not control dot, let's just copy and paste that. Okay. Oh, we need equals here. There we go. So we have the logged in user, and now we have the the user to add to the role. So now we can do down here, before we do the actual adding. I want to do this because in case this were to crash, I don't want it to crash without telling us that someone tried it. So let's go to our logger, which we don't have yet. We need to add that. Back to the top, back up here, we're going to say iLogger, control dot to add that using statement. And say iLogger for the user controller. Logger, control dot to create and initialize a field. And now we can go down here and we can say underscore logger dot. We have our choice of how we want to log this. Let's log it as just information. That's all it really is. And say, and notice the format. So the format is, we can use the curly braces and give it a name, and then we can put it in the parameters afterwards. So we're going to say, and this is not string interpolation. Don't use string interpolation here. Use this format instead. And the reason why is because for structured loggers, this will pull these items out and store them separately so you can do queries upon them. It's much more ideal. If you use string interpolation, it's just one big long string and you can't do any queries based upon it. So, or at least not easily. So this way with structured logging, we can pull out who the user was and say, give me all the actions that Tim did for adding or removing roles. And then it would list all the times I added or removed a role from someone and who that was. So really helpful. So admin, let's just say admin, added user, and we're going to say user to role. Okay, which seems really redundant. But what we're going to do now, let's put a semicolon at the end. What we're going to do now is say the first item in this array is going to be admin. So this is the logged in user dot, and we can give the first name, we can give the ID, last name. I think what we'll do here is, let's just give the ID, which actually you don't have to get then the logged in user. We have a logged in user ID. I'm debating. I think we just do logged in user ID and then not even get this line. Now, scan to the logs, that's going to be a GUID, which is not terribly helpful, but it would make this log message a lot longer, and I don't want to do that. Okay, so we're going to leave it at the user ID. Add the user, so the next variable is user, and that is user dot ID to role pairing dot role name. So now here's the three values you're going to put into this, this, and this respectively. Okay, but again, this is not string interpolation. Normally we put a $sign in front here, then these values be actual parameters. Don't do that because it will not save properly to a structured logger. We want this to be a string when it's just like the console, but we want to have the ability to pull out these variables separately in a structured logger like Seralog. Okay, so now let's copy this line right here. And let's come down here and we'll paste it in and we'll copy this line as well. Let's copy it from here, like so. And removed user from role. And there we go. So now there's a log for whenever someone's removed from that role as well. Let's just see if you can see this in the console. It should show up, I believe. So let's bring the console over here. Once it comes up. Oh, come on. Everything's popping up. So there's a console. There's a lot of stuff in here because of the fact that we haven't toned down the Microsoft logging right now. But that's okay. We're going to log in. It's going to hit a bunch more stuff. Let's go to user management. And now we can do is I'm going to select the user and I'm going to add a role of manager. All right. All right, let's go find that error message, which is not error message, that information message. We scroll up here. If we made it a warning or an error, it would pop out a little more clearly, but that'd be not great because we don't want it to be a warning. It's not a warning. Let's scroll up here. It should be in here. This is very verbose, but it's logging even the entity framework stuff. I should probably tone this down. It should be in here somewhere. Let's keep going a little bit more. I may have gone past it, but it's in here somewhere. I'm sure it is. Think about past it. What we're scanning for is any message that's not a Microsoft message. All right, there we go. Admin. There's the admin ID. Add user. There's the user ID to role manager. There you go. So now we have seen that it does log out to the console. So it's logging from the user controller. And this is what it's logging. So we've now added logging whenever we add a user. And let's just remove the user from that role, and it's going to generate a whole bunch more. But again, in there somewhere, and I don't want to search for it too long, but in here somewhere is, oh, there it is. Remove a user from role manager. So now we have a logging going on whenever the user does something that is not unsafe, but should be logged, should be tracked, so we know who did what, and we can kind of not assign blame, but we can have a history of what went on. And maybe if we found out the user doesn't have a role that we think they should, we can go back and find out who took away that role and why is it they took away that role. We can ask that person. So it can be really helpful. So let's stop this. And now we have logging in place. Let's go ahead and add those 3 items. Let's make sure we've saved everything. We think we have. We just ran it. When you run something, it saves it automatically. So we've added logging to the API. Now, I have not changed the logger. So logger is still a built-in logger that comes with the API. It logs to the console and application insights and the debug window. But that's it. If you wanted to add serial log, which you may do down the road, or another logging framework, nlog, log4net, those types of things, you can do that, and it's just a matter of changing the configuration for the logging, and all your log statements will go over to that new logging provider. So you can add logging before you've even decided what logging framework you're going to use, which is kind of convenient. One last thing I want to do, let's go over to the startup class. And in here, I pointed out earlier, we have this, my secret key is secret, so do not tell, which is for the issuer signing key, which is something that has to be very, very private and you don't give us away, but it's in my source code. That's not a good place for it to be. Let's put this into our, for right now, appsettings.json. And this is okay to do because appsettings.json should only ever hold development or even local keys. So if you have login names and passwords, they should only be for local systems that are developer systems that no one can ever have access to. And even if they deleted the whole system, it wouldn't matter. So Typically, I put my connection string, my personal connection string to my personal SQL server on my same machine that uses Windows authentication. Well, I'd put that into appsettings.json. And I'd commit it to source control, no problem, if it's just me working on the project. Now, if it's a team of 2 or 3, then what I'd do instead is I'd probably put it in my user secrets file, which does not get committed to source control. And so I'm not going to step on the toes of everyone else with theirs. I'll leave it blank. Now, when it comes to production, you won't use that same setting in appsettings.json. Instead, what you'll do is one of a few different things. One could be that you would have your build process replace that appsettings.json string with one that is specific to production. And that can be safe. So if you own the web server, or the web server is on Azure or wherever else, and only you have access to it, then that can be safe. That's fine. Because the only way they'd get access to that password is if they already compromised your web server, in which case it's kind of too late. So you've already kind of given away the keys anyways, so having the key there is not a big deal. But to take security to the next level, what you can do is you can put the connection string in Azure itself, in a protected spot in your Azure web app, or you can put it into Azure Key Vault, and then use that instead and point to that instead. And that's secured, encrypted, and all the rest. All that to say that don't put your production stuff in appsettings.json, but your development stuff is just fine. This is obviously a development secret. My secret key is secret, so do not tell. That is not a good key. Your key should be a lot longer, and it should not be just words crunched together. Instead, it should have lots of special characters and other things to make sure that this is random and not guessable very easily. So I'm going to move this to appsettings.json, which will allow me to use Azure Key Vault or something else down the road for my production system. To do this, it's actually quite easy. What we're going to do is, since we're in startup, so notice that we're in services here, which is where this is what configures dependency injection, which means we don't have dependency injection yet. But we do have this configuration, okay, which we have configured through startup, which means that we can access the configuration, which will talk to our appsettings.json. Therefore, down here, we can cut this out, Control X, and say configuration dot get value, we're going to say string, and then we're going to pass in a string here for where we're going to find it in a configuration. Let's say secrets dot, and this is the security key. Okay, so in appsettings.json, we're going to create a new section called secrets. And we have a security key. And we're going to paste in that value. So it's going to pull the value for secrets : security key, which is my secret key is secret, so do not tell. Basically, nothing will change as far as how the application appears to work, but instead of having that key hard-coded in our code, instead we're going to pull from the configuration in this particular spot, which gives us this value, which means we can replace this value down the road with something else. Okay, let's make sure it still runs. And we'd know if this will run or not based upon the fact that it logs in. So as long as we can log in, we're good to go. So we go to login, click the login, and we're logged in just fine. Log out, exit out. We can close our application. So now we have moved that key to the configuration system. Okay, We can save this. We can go over here and we can commit these changes. Again, we are committing that change to appsettings.json, which means that now in our source code on GitHub, it will list that key. But that's a dummy key that's just for development. It's not going to be used in the real world. Therefore, it's just fine. To configuration. Because it's not just appsettings.json, it's actually, we can pull from a lot of different places now. Commit staged. Now we can go over to our sync tab, and we can do a fetch to make sure there's nothing on the server that we need. There's not, so now we can push our 3 commits up to the server. And once we do that, then we will be complete for this lesson. We've done, basically we've taken advantage of the .NET Core dependency injection and configuration manager and the logging system to kind of upgrade, especially our API and the API library, so that it can be, better design, better more testable, so that that key is not hard coded, and so you know when someone adds or removes a user from a role. All these things are now possible and, quite frankly, easy because of that move to .NET Core. These things are just kind of built into .NET Core. All right, so that's it for this lesson. In the next lesson, I believe we're going to move over to Azure DevOps and start preparing that for using the bug system and the feature system in our boards to do some basic tracking of those things and start associating these bugs and these features with our commits. So you can kind of track through exactly what we did and when we did it and why we did it and all of that in a more professional manner, but yet it's still free as long as you can use Azure DevOps, which I believe up to 5 people can for free in most organizations. So with that, until next time, thanks for watching. And as always, I am Tim Corey.